the growth rate in y. You should be familiar with growth rates. And there are some rules that you need to learn involving growth rates. Suppose we have this. Z is equal to x times y. And imagine z, x, and y are all functions of time. Okay, z is a function of time, x is a function of time, and y is a function of time. What is the relationship, David, between the growth rate in z, the growth rate in x, and the growth rate in y? What is the relationship? Yeah, now, z is equal to x times y. But now what I'm asking, what is the relationship between the growth rate of z, the growth rate of x, and the growth rate of y? Let me give you a hint. The growth rate in z, one expression for the growth rate in z, David, is d log z dt. And in a similar fashion, the growth rate of x is just d log x dt. The growth rate in y, d log y dt. So I want you to tell me, given that z is equal to x times y, what's the relationship between the growth rates z, x, and y?
I have no idea.
Okay. Well, think back to logarithms. Let me ask you an easier question. What happens if you take the logarithm of both sides of this expression? Z is equal to x times y. Suppose we take the logarithm of z. Obviously, that must be equal to the logarithm of x times y. And what can we do to this right-hand side, David? What is the log of x times y?
It's like the log of, we can separate it so it'd be like the log of x.
Right? Go on. No, not times, plus. This is rule number 2. The logarithm of a product is equal to the sum of the logs, the log of x plus the log of y. Okay. You remember these 3 rules of logarithms? The first rule is this. We did it in terms of u and v. The logarithm of u times v is equal to the log of u plus the log of v. Also, the logarithm of u over v is equal to what, David? Right, it's the log of u minus the log of v. And the third rule was this. The logarithm of u to the a power is equal to? Right, a times the logarithm of u. Okay. Those are the rules of logarithms. You should know all those. Now, going back to this, David, we have log z equals log x plus log y. What do we have to do to figure out the relationship between the growth rates in these 3 variables? Well, look back at this. What is the growth rate in variable z? By definition, it's d log z dt. So the next step to get the growth rates is to do what? From this expression right here. Yes, just take the derivative with respect to time. And then we'll get d log z dt, which is by definition the growth rate in variable z, is equal to d log x dt plus d log y dt. Or in other words, the growth rate in variable z is equal to the growth rate in variable x plus the growth rate of variable y. Okay. So anytime you have an expression like this, the growth rate in z is just going to be the growth rate in x plus the growth rate in y. Let me give you an illustration. Suppose we're looking at the growth rate of total revenue. Total revenue is by definition price times output. So the growth rate in total revenue is going to be the growth rate in prices plus the growth rate of output. So the growth rate in total revenue is just going to be the growth rate in prices. And the growth rate in prices, what name do economists give that? The growth rate of prices is just what? Inflation. That's just inflation. So your growth in revenue will just be inflation plus the growth rate in physical output. Okay. Another illustration. Suppose we have z is equal to x over y. What's the relationship between the growth rates in these three variables? Jay? Exactly right. The growth rate of z is equal to the growth rate in x minus the growth rate of y. For example, suppose you're looking at the growth rate of consumption per person, or the growth rate in per capita consumption, little c. Little c is going to be big C divided by, let's call it population. Okay. So little c is consumption per capita. Big C is total consumption divided by population. Okay. This would just be the definition of consumption per capita. Let's just define little c to be big C over population. Then if you're interested in the growth rate of consumption per capita, it's going to be equal to what, Jay? The growth rate of little c is just going to be the growth rate of consumption, total consumption, the growth rate of total consumption, big C, minus the growth rate of population. Okay. So if you got the growth rate in total consumption, and you subtract the growth rate of the population, you get the growth rate of consumption per capita. Okay. The more rapidly population is growing, the lower consumption per capita will be for any given value of the growth rate of total consumption. Okay. So if population is growing very rapidly, that's going to tend to depress the growth rate in consumption per capita. Okay. One more rule. Suppose z is equal to x to the a power. And you want to know what is the relationship between the growth rates of z and x. There's no y in this one, just z and x. How would we get that? What is the relationship between the growth rates of z and x? Well, if you don't see it right away, what would be a good way to begin to figure out the answer? I'm sorry, I didn't hear you. Johnny, did you say something, Johnny? Oh, take the log. All right, who said take the log? Jay, that's right. Okay. So take the log of both sides. Take the natural log, and you get the logarithm of z is equal to what, David? Well, okay, that's our, go ahead, the log of, yes, raised, okay. It is the log of x raised to the a power. And what is the logarithm of x raised to the a power? Yes. Okay, you just use a rule number 3 and bring that down. Now, Bernard, what do we do to get the growth rate in z?
Z as the derivative of natural log of z
Okay, with respect to,
time.
right, exactly right. Just take the derivative of log z with respect to time. And obviously that is going to be a times the derivative of log x with respect to time. Okay, we're assuming that z and x are both functions of time. Now you've got it, because d log z dt is, by definition, the growth rate in z. The growth rate in z is equal to a times the growth rate of x.